Doesn't that instill, that picture instill a sense of grandiose power too?
No, it instills a sense of I'm probably drowning right now.
Oh, okay. Well, maybe. Doom and despair? I won't take too long. Power refers to the rate of doing work. How fast can you do work? You could also say that it's the rate at which energy is transferred from one object to another. How fast is energy transferred? If you are increasing the speed of something, how fast can you increase the speed of the car? The Mustang has a lot of horsepower. It gets the Mustang up to a high speed quite quickly, right? Refers to the amount of work done per unit of time. Right? So it's work per unit of time. So what is the formula? Power equals work over time. P equals W over T. That, I was just about to say that would be your last equation, but I would lie if I said that. So I won't say that. Power equals work over time. It's pretty straightforward though, right? Power equals work over time. Generally, time is measured in seconds. Now, what are the units, might you say?
Actually, it's not very straightforward.
T equals W over T isn't straightforward? No.
It's got to be lifting.
It's got to be lifting?
You have to move it up to
No, you could be moving it sideways. You could be increasing its speed. If power equals work over time, and work is measured in joules, and time is measured in seconds, then the unit of power is joules per second. Is there calorie content on that drink you're drinking there?
Yeah.
Is it measured in joules?
Yeah.
No? Anybody check out the Vector cereal box?
Capital C.
It's capital C, that means kilocalories. Joules per second. Now, it just so happens that joules per second are defined to be 1 watt. Named after James Watt, developer of the steam engine, right? The same watts that we talk about, whether we're talking about light bulbs or stereos or whatever else you might talk about in watts. Okay? People tend to talk about engines in horsepower, but it's really measuring the same thing. Okay? So it's joules per second or watts. So here's a quick sample question. What power does a 50 kilogram girl develop, or what power does she require while running up a 2-meter high flight of stairs in 0.75 seconds?
We're going to figure it out.
We're going to figure it out. We're going to figure out what her horsepower is, measured in watts. So she's 50 kilos. She's running up a 2-meter high flight of stairs, and it's 0.75 seconds. She has to do work against the pull of gravity. The force that is required is the force against gravity.
Can you still run now?
We're going to run right away, yeah. So it's should I pause here for a second? Okay, so let's just do this here. So it's going to be power equals work over time. I apologize for the non-ocean look there. Couldn't get it to work with the equations very well. So power equals work over time, but the work done is equal to force times distance. What force are we talking about? Weight force, which is going to be mass times gravity times distance. So she weighs 50 kilos times 9.8 is our gravity times 2 meters over 0.75 seconds.
Wait, so this formula is only used for lifting it?
No, not necessarily. In this example, it is because it's lifting, right? But it could be.
Or like M times G. That's still.
That's just because
Still matters for moving, like you're pushing something.
This work could be mgd, which is involved when we're lifting, right? And that's kind of potential energy as well. Or it could also be kinetic energy, which is 1/2 mv squared that you're going to see tomorrow. Okay, so it's just work over time. It's whatever type of work is happening in that particular scenario. Okay, so in this case here, it's 50 times 9.8 times 2, or 0.75, or 1,306.7 watts, or 1.31 kilowatts. That's a whole lot more than a 60-watt light bulb.
That means that if she ran up those stairs, she could make light bulbs turn on.
I saw something yesterday online. A kid figured out how to put, there's these things called piezoelectric crystals, and when you stress them, when you compress them, they produce a small amount of electricity. So he actually figured out a way to put one inside a shoe, a runner, and he had a little USB coming off, and he could charge up an iPod Shuffle that he attached to his shoe just by walking around with it. That was pretty cool. He was 13.
Whoa. Nerd.
Yeah. Okay, so that's pretty straightforward, I think, is it not?
So what kind of thing did he put in? It was like a little, like,
So crystal that when you stress it, when you compress it, it produces a small electrical charge. So when you do it like over and over and over again, it produces enough current to.
things that, so you could have anything.
Good.
Go for a run. What do you-
What? Of course, note that 1 kilowatt is equal to 1,000 watts, right? Kilo meaning 1,000, as it always does. Now, the textbook uses a slightly different formula.
Small KW.
Yes, actually correct, yes. Small kVW. Textbook uses a slightly different formula, which I just want to point out, because power equals work over time, and work can be written as force times distance. Keeping in mind that velocity equals distance over time, there's my d over t. See that? So what am I going to get here? I'm going to have p equals
Velocity. Your speed.
p equals velocity. I'm going to replace this. I'm going to plug it in there, and I'm going to get power equals force times velocity. Okay, so that's an example of a non-lifting type of situation, right? Power equals force times velocity. Okay, there's a few textbook questions there that you can put in your, just jot them down. You might want to have a look at them. You'll have a little time to work on them later, or even possibly you might have to do some at home. Is there anything else? Oh yeah.
Then we get a full page.
Can you go back?
Full page for the exam.
Oh,
What? Can you go back?
First, let's enjoy Super Grover.
Is there a video with this?
No,
I just wanted the textbook question.
I don't.